Difference of two squares identity solved problems. Problem 1. Factorize m to the 4 minus n to the 4. M to the 4 minus n to the 4 equals m squared squared minus n squared squared, which equals m squared plus n squared times m squared minus n squared, which equals m squared plus n squared times m plus n times m minus n. Problem 2. Show that x to the 4 minus 1 equals x squared plus 1 times x plus 1 times x minus 1. X to the 4 minus 1 equals x to the 4 minus 1 to the 4, which equals x squared squared minus 1 squared squared, which equals x squared plus 1 squared times x squared minus 1 squared, which equals x squared plus 1 times x plus 1 times x minus 1. Problem 3. Use difference of two squares to show that 99,999,999 equals 10,001 times 101 times 11 times 9. Now note that if we let u equal 99,999,999, then u equals 100 million minus 1, which equals 10 to the 8 minus 1, which equals 10 squared to the power 4 minus 1. Then, from the previous problem, we have u equals 10 squared squared plus 1 times 10 squared plus 1 times 10 squared minus 1, which equals 10 to the 4 plus 1 times 100 plus 1 times 100 minus 1, which equals 10,001 times 101 times 99, which equals 10,001 times 101 times 11 times 9. Problem 4. Factorize fully p cubed q minus pq cubed. P cubed q minus pq cubed equals p squared pq minus pq q squared, which equals pq into p squared minus q squared, which equals pq into p plus q times p minus q. Problem 5. Factorize fully a to the 5b minus ab to the 5. A to the 5b minus ab to the 5 equals a to the 4ab minus ab b to the 4, which equals ab into a to the 4 minus b to the 4, which equals ab into a squared squared minus b squared squared, which equals ab into a squared plus b squared times a squared minus b squared, which equals ab times a squared plus b squared times a plus b times a minus b. Problem 6. Use difference of two squares to calculate 12.7 times 11.3. 12.7 times 11.3 equals 12 plus 0.7 times 12 minus 0.7, which equals 12 squared minus 0.7 squared, which equals 144 minus 0.49, which equals 143.51. Problem 7. Solve m squared minus n squared equals 221, given that m and n are positive integers. Recall that n is the set containing 1, 2, 3, 4 up to infinity, so m and n must be integers taken from that set. So we're only looking for whole number solutions to this equation, and indeed positive whole number solutions to the equation. We have m squared minus n squared equals 221, which implies that m plus n times m minus n equals 221 by difference of two squares factorization. Now, 221 has exactly two factorizations using integers. We can write it either as 1 times 221 or as 13 times 17, which is the prime factorization. So using the first factorization, we can write m plus n times m minus n equals 1 times 221. Using the second, we can write m plus n times m minus n equals 13 times 17. Notice that m plus n and m minus n are integers, and that m plus n is greater than m minus n. Then using the first factorization of 1 times 221, then that means that we can only have solutions if m plus n equals 221 and m minus n equals 1. And using the second factorization, we must have m plus n equals 17, m minus n equals 13. So we have two sets of simultaneous equations to solve. So in the first case, m plus n equals 221, m minus n equals 1, and adding we get 2m equals 222, so m equals 111. Subtracting, we get 2n equals 220, so n equals 110. And in the second case, m plus n equals 17, m minus n equals 13, then we get 2m equals 30 by adding, so m equals 15, 2n equals 4 by subtracting, so n equals 2. And notice that in both cases, m and n are positive integers as required, so these are valid solutions. And we can, of course, check these solutions by substitution into the original equation, as I've done here, with 111 squared minus 110 squared indeed being 221, as you may check, and similarly for 15 squared minus 2 squared. Problem 8. Solve x squared equals y squared given that x and y are real numbers. X squared equals y squared implies that x squared minus y squared equals 0, so x plus y times x minus y equals 0. Then we apply the key fact that if a and b are real numbers, then if a times b equals 0, then either a equals 0 or b equals 0. So in this case, we must have either x plus y equals 0, which means that x equals minus y, or x minus y equals 0, which means that x equals y. And a specific example of this result would be if x squared equals 4, then x squared equals 2 squared, so we can immediately say that either x equals 2 or x equals minus 2. Problem 9. Simplify fully x plus y to the power 4 minus x minus y to the power 4. Let p equal x plus y, q equal x minus y, then x plus y to the 4 minus x minus y to the 4 equals p to the 4 minus q to the 4, which equals p squared plus q squared times p plus q times p minus q from previous results. P plus q equals x plus y plus x minus y, which equals 2x. P minus q equals x plus y minus x plus y, which equals 2y. P squared plus q squared equals x plus y all squared plus x minus y all squared, which equals x squared plus 2xy plus y squared plus x squared minus 2xy plus y squared, which equals 2x squared plus 2y squared, since this term and this term cancel, which equals 2 into x squared plus y squared. So x plus y to the 4 minus x minus y to the 4 equals p squared plus q squared times p plus q times p minus q, which equals 2 into x squared plus y squared times 2x times 2y, which equals 8xy times x squared plus y squared. Problem 10. Simplify sine to the 4 of theta plus pi by 4 minus sine to the 4 of theta minus pi by 4. Now, first note that sine theta plus pi by 4 equals sine theta cos pi by 4 plus cos theta sine pi by 4, which equals 1 over root 2 sine theta plus cos theta. And sine theta minus pi by 4 equals sine theta cos pi by 4 minus cos theta sine pi by 4, which equals 1 over root 2 sine theta minus cos theta. So, raising both sides of those identities to the fourth power, we have sine to the 4 theta plus pi by 4 equals 1/4 sine theta plus cos theta to the 4, and sine to the 4 theta minus pi by 4 equals 1/4 sine theta minus cos theta to the power 4. If we make the substitutions x equals sine theta, y equals cos theta, then our original expression becomes 1/4 into x plus y to the 4 minus x minus y to the 4, which from the previous problem becomes 1/4 times 8xy times x squared plus y squared, which equals 2xy times x squared plus y squared. And recalling our x and y substitutions, this becomes 2 sine theta cos theta times sine squared theta plus cos squared theta. And if we recall the identity sine squared theta plus cos squared theta equals 1 for all theta, then this expression becomes 2 sine theta cos theta, which equals sine 2 theta.